start today by talking about or finishing worksheet 2. Yesterday in this class, we got through number 1. All right, we did Pythagorean theorem. We looked at where theta was and labeled them opposite, adjacent, and hypotenuse. We ended up with some ugly radical answers, and we had to rationalize, and we did the reciprocal functions for a good time. All right, I'm thinking about skipping to, we did 3. We got further than any other class, but we did Pythagorean theorem in green right here. And then we wound up, again, we labeled this opposite over hypotenuse, drew the picture. Then we went through and found all the functions and flipped them all over, and it was a big hot mess. Okay. Thinking we should do one more of those real quick, even if since the other classes are behind anyway. So what is secant, guys? So cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. Now, you could use just Pythagorean theorem to find the missing one. I really like to draw the picture and label it because it helps me think about what's going on here. So if I label the hypotenuse 8 and adjacent to this angle, wherever you put your angle, 5. So I'm missing a leg. So I have 5 squared plus that opposite side or leg, or I'll just call it x squared, equals the hypotenuse, or 8 squared. If I subtract, let's see, 64 minus 25, 39? So x is the square root of 39. Lovely. All right. Well, the good news is only things with opposite are going to have that radical, right? Not everything. So we're supposed to do all 6 trig functions. I'm going to do them in the order that they would be on your calculator: sine, cosine, tangent. Okay, so sine is what? Somebody tell me. Okay, opposite over hypotenuse, which would be square root of 39 over 8. Cosine should be the reciprocal of this, right? Adjacent over hypotenuse. Tangent, opposite over adjacent, which is over 5. Okay, so the one that we need to, well, we got 2 of them we got to flip over. They're going to be a little messy, right? If you flip over sine, you'll have cosecant, which would be 8 over square root of 39, or 8. How is that going to rationalize? Do I need to show the work for that, or you got it? Multiplied by square root of 39 over square root of 39. All right. Let's see, what am I missing? Secant was given. I'm going to put it in my list down here, though. Cotangent. Okay, we got to flip over tangent. So again, we'd end up with 5 square roots of 39 over 39. Now, on the quiz, I do not ask you to find all 6 of them because I think it's just painful. I just picked a couple. Does that make sense, guys? I might give you cosecant and tell you to find tangent and secant. Who knows? Okay? I didn't make you find all 6. All right. I think I'm on the back now. Am I on the back now? Okay. It says to solve a right triangle means to find all of the missing signs or angles. I kind of feel like we already pretty much know how to do this. Oh, we're going to do some application problems. That's what we're going to do. Angles of elevation and depression are always up or down from a horizontal line of sight. Let me tell you what happens on the quiz, and no one's going to do this, right? It says there is a tower on some question, and of course the prince is up here, and the princess is out here, and she needs to save him because princesses are powerful, right? Oh, she needs a hat? Okay. So the angle of depression from his line of sight is given as like 26 degrees. And I have students do this. Is that how that works? It's always from the horizontal, so that's how far he has to look down is 26 degrees. Or how far she has to look up is 26 degrees, and those are equal because, do you remember this? Alternate interior angles from geometry, they make that Z. He's looking down or she's looking up, here and here, the same amount. All right. So this is angle of depression. It's always from the line of sight, or from the horizontal, up or down. All right, I've killed that idea. So the Leaning Tower of Pisa, okay, I doubt it leans quite that much. What do you think? But anyway, oh my gosh, the ground isn't even straight. Let me try that again. Okay, the Leaning Tower of Pisa is about 55.9 meters tall and is leaning so that it's only about 55 meters above the ground. So this side, when they built it, was 55.9 long, but right now it's leaning enough that it's only 55 above the ground. Is that making sense? Okay, at what angle is the tower leaning? So what angle do I want to find? Yeah, this little angle over here. Normally, we would like a building to have that be a 90 degree, right? But it's leaning over, so it's not 90. Hopefully, it's not like 30, because that would be leaning a little much, but okay. Yes. So this is opposite. We need to go a little quicker here. This is opposite. This is hypotenuse in our little triangle. So we have the sine of that angle is 55 over 55.9. So we need to type second sine of that. And we need to be in degrees because all application problems are normally in degrees, right? So your calculator should say degrees at the top, or go to mode and make sure it's in degrees. But please be doing this so that you can check that it's working right for when we get on to other stuff here in a minute. Was it 55 over 55.9? Thank you. Okay, 79.7. Wow. It's more than I thought. It's about 80 degrees, so it's got a 10% or 10 degree lean in it. Everybody good? Submarines 250 meters below the surface of the ocean. Okay. Ocean down to submarine. I don't know what that looks like. Okay. 250 meters. Begins to ascend. Okay. Well, mine is pointing this way, so he's going to have to come up this way. At a 22 angle from the vertical. Okay. Very rarely do we use from the vertical, but this specifically says from the vertical, right? So in here, between that sub and the vertical line is 22 degrees. He's cranking it. How far will the submarine travel before it breaks the surface of the water? Okay, so the sub's path is here, right? My pathetic little submarine. Well, now he's going backwards. I don't know. He's going this way, so his actual path is here. So that's what we want to find, which is the hypotenuse. Now this looks like a 7. It's supposed to be my periscope. Anyway, So we have a right angle here because we measured depth straight down from the surface of the water. So this is the hypotenuse, this is the adjacent to our 22-degree angle. Which function is that, guys? Cosine of 22 degrees equals adjacent over hypotenuse. If I cross multiply this way, I get 250. If I cross multiply this way, I get cosine of 22x, so I need to divide by the cosine of 22 to get the x by itself. 269.6, anybody? Make sure you label your answers on application problems. Questions? Number 7. I don't know if we talked about ladder question very briefly yesterday, but guys, the ladder is always leaning. It's the hypotenuse over here, okay? Please do not make the ladder straight up and down. 70.1 is the angle between the ladder and the ground. How far up the side does it reach? So that makes x here, which would be opposite of that angle. When we know the hypotenuse, which would be which function? 70.1 equals x over 10. So 10 times the sine of 70.1. Wasn't that 10? Oh, 30. I wrote over the top of it. Thank you. Yeah. Okay. 30 times the sine of, anybody get an answer? $22? 28.2 feet up the side of the house. And then part B says how far, what is the horizontal distance from here down here? So I'm going to call that y, and that would be adjacent, which means I would need cosine of 70.1 equals adjacent over hypotenuse, or 30. Anybody get that one? Really? 10.2 feet. Anybody else think that's seems pretty far to have a ladder out? Well, it's a 3-story ladder, yeah.
But that still seems.
Well, if you went up 3 stories.
You don't want to be too steep, I guess.
But I meant the angle. It doesn't seem like a nice hill. Going.
Oh.
Losing.
Yeah.
Going up,
Observation, a person standing. Okay, this is the kind that gets a little tricky because I think we have to do 2 separate steps here, if I remember right. Person is standing 100 feet away from the bottom of a cliff, notices a tower on the top of the cliff. The angle of elevation to the top is 30, no, to the top of the cliff, okay, right here, is 30 degrees. The angle of elevation to look to the top of the tower is 58 degrees. We're supposed to find just the height of the tower. Now, we could do this if we had enough information, which we don't. We could do this with law of sines or cosines. Well, maybe we actually would be able to do it. I think we would. But I'm going to do it by solving 2 separate triangles. We have the big triangle and the little triangle in here. So the big red triangle has a 58-degree angle here and 100. And if we find x, it will give us the height to the top of the tower. And then the little triangle inside is still 100 here. Is that 30, guys? I can't read that number. 30 degrees? What is the height of the tower? They want the tower only.
Oh,
So we have to subtract when we're done, okay? We want the height here. So if I go climb up the tower, how far am I climbing up? So that is going to be x minus y. All right, so calculate those up real quick. These are both tangents, right? Yep, I did something wrong. Oh, I typed this first one wrong. Okay. $160, should that be $160 for this first one, guys? And this one's 57.7. And the difference would be the tower. What did you get through today, Miss Abruzzo? Okay. Okay. Got about 102.3 feet is the height of the tower. Someone else get that? Okay. Questions? I think there's one on the quiz that, or at some point there was one like that somewhere. All right, we are moving on to worksheet 5. If I can find the right place. All right, I'm trying to skip around quickly because some of this we did yesterday. So I need you to shoot me a slow down if I'm going too fast on some of this, okay? First of all, vocabulary. Do you remember all this vocabulary, guys? Terminal means where it ends. We talked about coterminal means two angles, two names that end in the same spot. Vertex, initial side is where we start, and we start from the positive x-axis. We good? Positive meant we were measuring from the positive x-axis going counterclockwise. Okay. Oh, this is something new they throw in here. Can you change between degrees, minutes, and seconds and decimal degrees? Okay. I can show you how to do it on the calculator, but there are 60 minutes in a degree and 60 seconds in a minute, just like hours, okay? 60 seconds to make 1 minute, 60 minutes to make 1 hour. Same works for degrees and minutes. So to convert this into degrees, minutes, and seconds, you would multiply the decimal part by 60, then take off the decimal part of that and multiply it by 60 again. We're just going to use a button on the calculator. So it is 56.735. Do you see where it says angle, anybody? Second apps. Second apps. And you're going to just pick number 4. Degrees, minutes, and seconds. I thought that had a 6 sec. Oh, there. I was just not on the screen. I didn't see it. Okay, we're good. Now, if I go to the next question, if I could figure out how to get to the next question, it says when you have degrees, minutes, and seconds, you can change it back. Now, I'm kind of old school about this. I usually do this by dividing. So I go 32 plus 5/60 plus 28. Now, be careful. How many seconds in an hour? It's not 60. Yeah, 60 times 60 is 3,600. So that's how I type it in when I do a question like this, because it's a pain in the butt to find all the other buttons. But I'll show you where they all are. Okay. 32 degrees, we're supposed to type in 32, and then it's back to angle, second apse. There's a degree symbol. The next thing is 5 minutes, so you put 5 second app minutes, which is the second. The tricky one is the third one, the seconds, 28 seconds. Seconds are actually on the home screen. It is above the plus sign, I think. It's alpha plus.
I just clicked I put on 0, then there's degrees in a second, and then I just use a little caret to make it so I can type in there.
Say that again. You went to angle.
I just do this, and then it gives me all the little 3 numbers, and then I go here, and then.
Oh, never would have thought of that. Okay, so what he said was he did 0 and then went to degrees, minutes, and seconds, which is choice 4, and hit enter. Because then if he went back up, he can go in and type over the top of all these.
You click the caret key so you can type in more than
Oh.
just like the caret key.
Here now?
And then you
No,
click to the side.
wait.
You go to
Clear. Go back here and click the caret key.
Here. Enter. You go to the 0, click the caret key, and then you can go over to the side, and then.
Oh, yeah. Okay, I don't know that that's as good as I thought it was. What he says is he went back here.
You go over to each one, and
Well, yeah.
then you just go over to the side.
Yeah. Okay, I didn't think it was that exciting. He went back here, but then to be able to put in 32, you could go second insert and make that a 3 and then make it a 2. This is not that exciting to me now anymore. Okay, then 5, and then what he said is he went here and did the caret and then arrowed to the left, because then it would let him put in 28 and it would ignore that caret box up there. Oh, then you had to delete. Oh my goodness. Okay, we just wasted a half hour. I don't think that's, okay. Where's the second one again, guys? The seconds, how do you get the seconds? Alpha plus. Okay, do these two real fast right here. Think you have them on your notes. 213.875. Angle, degrees, minutes, seconds. 213, 52, and 30. Anybody else get that? Okay, and the last one, 89, 56, and 7. 213, thank you. $89. You guys are all done. I'm so slow at this. What was it? I already forgot. 56 and 7. Oh, it's alpha, isn't it? $89.935 if we went out that far. His way? Okay. Oh, yes. This is way faster than finding all those buttons. Yes. The old-fashioned way. Okay. Moving on. Okay, we need to talk about angular linear velocity, arc length, area of a sector, all the stuff students hate in this unit. Okay? So I need to be awake, paying attention for this part. We talked yesterday about if you took a string and you measured off this radius, and you measured off this piece of the circumference and they were exactly the same, this angle would be 1 radian. Okay? So the arc length would equal the radius if theta was 1 radian. Well, the formula therefore is derived that S equals R times theta, and you will have that formula on a reference sheet. Do you know where I am? Am I on 5B or what? 5B? Okay, sorry. Thank you. Okay, 5B. So they give it to you here as theta equals S over T, but that's because that's, well, S over R. See, I can't even read. That's if they're solving for the angle. So arc length is R times theta, or the angle is this in radians. Why do we use radians for all these formulas? Well, it has to do with the fact that a degree has no relationship to any angle measure. Okay? I'm sorry, to any linear measure. There's no such thing as an inch per degree or degrees per inch. Okay, if I say this is 30 degrees, then we want to find this distance, then we have to know the we have to deal with the circumference and the part of the circumference. This makes formulas easier later. It says, notice that as long as the arc length and radius are using the same linear units, then when we divide out, it's unitless. For this reason, the word radian or its abbreviation is usually omitted. Okay, guys, it's the magic label. Radians will disappear and reappear when there's no label. Okay, it means it's in radians. So we're going to talk about, we already converted. We good? Degrees to radians, radians to degrees. Okay. Oh, this is a real quick review. I think I'm back on 5A. I don't know. Coterminal at the bottom. I don't know why it goes back and forth, but it does. The two positive coterminal angles differ by 1 full. We did this yesterday. I don't think you need to write this. Did we do this yesterday? Okay, so when it says all in the directions, that's when we have to put on that plus or minus n thing. So let's just do these 3 real quick. Degrees or radians? So if we wanted to name every angle ever that was coterminal with that, we would add on rotations that are in radians, which would be what? 2 pi. That's 1 rotation, okay? But because it wants all of them, we're going to put an n on here and say n is any integer. Now, I'm going to be real kind and not make you write n is any integer for everyone, but you need to understand that that's why this works. It's because you could add 1 rotation, 2 rotations, -5 rotations, and you'd get multiple names the same. So real quick, number 3, what do we write there? 135 plus or minus 360 n. And the last one? Okay, what if I wanted 1 positive name and 1 negative name instead of just all names? So you could put 5/3 plus, let's see, that would be 6/3 would be 2. If you added it once, you'd get 11/3. If you subtracted it once, you'd get -1/3. So there's 1 positive and 1 negative. That's not what it asked for, but I'm just reviewing what was yesterday's. All right, now we're to arc length, 5B. That other slide was just Okay, I didn't talk about it well, that's the problem. It was actually supposed to just talk about what a radius is, I think. All right, so it says down here, you have this in your notes, I think, arc length, if theta is a central angle in radians, then the arc length is r times theta. But you have to have theta in radians. All of the formulas we're using today, from here on out, have theta in radians. How do we convert between degrees and radians again?
181.
Yeah, either pi over 180 or 180 over pi, right? Everybody awake? Okay. The rate down at the bottom here is very important. It says the rate at which an object moves along a circular path is called its linear speed. The rate at which it actually turns is called its angular speed. Okay? So if I were to talk angular speed with an engineer, we would be talking about like RPMs, rotations per minute. Does that sound familiar? Revolutions per minute? Okay? But when we use the formulas, we have to change those to radians. All right, suppose an object moves at a constant linear speed along a circular path. If the arc length traveled during time, speed can be given by this, so it's arc length over time. If the angle of rotation is in radians as it moves through time, then the angular speed is revolutions or radians per time. Radians, okay. This is what it's written on your notes. I always just think of these based on the labels. Suppose an object's moving at constant speed. If s is the arc length, the linear speed v is given by the arc length divided by time. Why does that look like there's a, I don't know, it's supposed to be s over t. What are some labels that would give you distance over time? Somebody give me a distance label. Miles, okay, per time, or meters per, that would make no sense. Oh my gosh, give me a minute here, I'm having a moment. Meters per second, miles per hour, feet per second, okay? Anytime you have a distance divided by time, you have a linear speed. Okay, everybody get it? Anytime you have a distance over time, it's a linear speed. If the angle of rotation is measured in radians, then the angular speed would be radians per time. So radians per second, radians per minute, etc. It's got to be in radians. The other formula that converts between the two is the linear speed is the angular speed times the radius. I don't know if that's coming up on another slide here, but you might want to write that one down. You know the angular speed, if you multiply by the radius, you'll get the linear speed. All right. This is an example. Do you not have this one maybe? So help me real quick, or it's done for you maybe? Okay, so help me think through this. Determine the angular speed and linear speed if 8.2 revolutions are completed in 3 seconds and the distance from the center of rotation is 7 centimeters. Okay, so the distance from the center of rotation is the radius. Everybody good with that? Okay, 8.2 revolutions is nothing we can work with. We need to make it into radians. 1 revolution needs to cancel, and 1 revolution is how many radians? Everybody good with that? Once around is 2 pi. So now the revolutions go away, and I'm going to leave it exact for a minute. If I take 8.2 times 2, I get 16.4. How did I do? Is that right? Okay, 16.4 radian, pi. Pi is still in there, radians. Okay, that is our angle theta. It's not really a theta or an angle until it's in radians. It's actually Oh, and then it says in 3 seconds. So we can find the angular speed real fast. How are we going to do that? Angular speed. What kind of a label does angular speed have? Radians per time, right? Do we know radians? 16.4 pi radians. Time is 3 seconds. Let's go ahead and divide that out. 16.4 times pi divided by 3, 17.2. And that was radians per second. And that is an angular speed, so it's the little W looking thing. All right, the linear speed has to be distance per time. Well, what do we know about distance? The radius is 7. Okay. I would use the one I just showed you, this one. Okay. The angular one we just found times the radius of 7 inches, centimeters. So if you take that answer we just found, I leave the whole decimal on mine, times 7 inches, I got 120.2, but if you round it, you probably get a slightly different answer, which is fine. Just show your work. I got 0.2. I don't know what you got. And now it's centimeters per second. But guys, I need you to understand, look what happened. We multiplied centimeters by radians per second. What happened to radians? Yeah, magic, they just disappeared. So this is the linear speed. Okay, is that what your worksheet had? Something like that? Did they round differently, or am I close on the 120 something? Okay. All right, find the rotations in revolutions per minute. They do some weird stuff here. This is 2.7 radians per second. We want to change that to revolutions per minute for some weird reason. So how do I get rid of radians? Put radian, well, yeah, radians needs to go on the bottom, and I want what? Revolutions, yes, are what's equivalent? What do you know about a revolution and radians? Okay, now this is going to get messy, guys, because the only way you're going to keep both the 2 and the pi together in the denominator is to put them into parentheses when you type on your calculator. Otherwise, it's going to put the pi back up top when you multiply. That would give us revolutions per second, but they want it per minute. So what do I need to do? I need seconds to go away, and I need minutes to come around. So what is true about seconds and minutes? 60 seconds is 1 minute, and now the seconds label will cancel, and I'll be left with revolutions per minute. Now, I got to multiply everything on the top and divide by everything on the bottom. So really, I have 2.7 times 60, and then it's divided by, the only thing really down there is a 2 pi. 2.7 times 60 divided by, now if I don't put parentheses, I don't get the same answer. Okay, does everybody see you gotta have those parentheses? We're dividing by 2 pi, so 25.8, did you get that? All right. I'm going to go through this one really fast. So 4 pi over 3, this is currently radians per hour. Radians needs to go away. They want, for some silly reason, revolutions. 1 revolution is 2 pi radians. I need to change this also to minutes. So I need hours to go away up here. So this time, when 1 hour is 60 minutes, so the 60 goes in the denominator. Hours cancels, radians cancel. So up top, I have a 4 pi and a revolution. On the bottom, I have 3 times 2 pi times 60. I could put that all in parentheses to divide by it. Couldn't I also just do this? Okay, I just did a little reducing, so I got 2 over 180 or 1/90th. Or a decimal, is it 0.08 something? Did anybody actually type all of it in the original way? 0.0111, is that what you got? It's 0.01 repeating. And it's revolutions per what? Minutes. All right, moving on. Those are gross. I don't think we put one on the quiz anyway. Number 7. Given the linear speed of 24.8 meters per second and the angular speed of revolutions per minute, which is actually not good because it's not in radians. Supposed to find the radius. Okay, this is the relationship, right? Linear speed is angular speed times radius. How we doing? Does that look familiar, guys? So how do we solve that for r? Because we're supposed to find the radius. What do we have to do to get r by itself? Yes? Okay. The problem is this is not right. They're trying to trick us. 120 revolutions per minute we cannot use until we change it to what? Radians. So 1 revolution is 2 pi radians. So we get 240 pi, don't lose that pi, radians per minute is the angular speed. And the linear speed was this one. So what are we supposed to do with those in the end? Divide. So 24.8 meters per second is being divided by 240 pi, which we're going to need parentheses, radians per, oh, poop. We can't do this until they're the same label. What else do we got to change? Yes, we need the minutes to seconds. So I should have also multiplied this by 1 minute is 60 seconds. So if I divide this by 60, I get 4 pi. Okay. I got 240 pi over 60, which would reduce to 4 pi, and we're radians per second, yes? So that's what goes down here. Not 44, Rhonda. Now I can't even remember my own name. Radians per second. Okay, why are the seconds going to go away? This is per second and per second, right? The per second divides out. We end up with meters per radian or just meters because the label goes away. These are horrible questions. 24.8 divided by parenthesis 4 pi. Anybody get 1.97? Or about 2 meters is the radius. Are we done at 30? All right. So what you need to be working on is finishing up the book page that's on page 6B, doing worksheet 6B and 7A. So you need to finish up the stuff from yesterday. So you should have done all the circled problems on, was it 3 and 4 yesterday, guys? And now 6B and 7A. All the circled problems on those eventually. I'm not sure you're really ready, so come with questions maybe on what you didn't get to on 6B and 7A.
So it's the other thing Steven stood for.
Okay.
So now.